again, everyone, for joining in for today's webinar. It's to understand the jargons which are used in EV sector. For sure, there are a lot of jargons which are already I've mentioned here. And when I would go to somebody's at a customer meetings, I would go to some of the online meetings with some of the clients. We will have a lot of this, jargons which sort of people speak. They work in industry, and day in day out they've picked up these words to be very complex, and they made it shorter, right? So the interesting thing is, like, it just happens to someone that hey, when you are in an EV meeting, or let's say you went to some auto expo, you're trying to meet somebody. They're trying to tell some words which are very peculiar in a way that we don't just understand them. Yeah. So I was just trying to kind of pick those words and kind of go a little behind the theory and also the technical part of it. That's when the idea came in that hey, why don't we sort of conduct a session, and that kind of also helps everybody to learn what these components are, what's this abbreviations are, and things like that. Great. So that's how this session has just brought into life. And thanks a lot for all the CAP members, which is basically the Campus Ambassador Program members at Decibels, to get this whole program curated and spread the word across the whole community to join for the session. And thanks a lot, everybody, for joining in to take ahead. So I will try to have this session more interactive. It means you can ask more questions. So if you ask questions, then I can be more elaborative, or I can be more descriptive on the requirements, or I can also go a little behind what has been already defined as a part of the content. So we try to be limited to the time. That's about 30 minutes. So try to be interactive as much as possible. Great. So let's start with the very first one. A lot of people have this idea, there is something called EV, right? So we call EV for everything, but again, there is a very specific things when we call as BEV and when we call as an XEV. So the BEV is something which is the source of energy is only from the battery. Okay, there is no other source of energy. So that would be the very specific definition we call as a BEV. And there are a lot of people also call, like, the XEVs. The XEVs are something where you have the source of energy in maybe also from engine. You have also the energy from possibly, let's say, the source like the fuel cell. Yeah. So that would be called as an XEVs. So the source of energy can be from any different location. So usually we have the source of energy that can be from battery, and there's only two modes of possible charging for the battery. Okay, the possible charging can only happen through the charging station, or the charging can also happen through the regenerative braking. That's how the EV side would work, right? So, but if you see for the side of the HEVs, which is basically range extended or extended range electric vehicle, or it is a plug-in hybrid vehicle, or it is like also called as a hybrid. So again, in that you get a lot of different varieties. So you get something called micro hybrid, and you get something like a mild hybrid. Then you get full hybrid. And then you get plug-in hybrid. So it's basically the degree of hybridization, how much hybridization you want to. So the more the hybridization you go to, the more the battery pack would increase, and more the range which you drive with EV as an sole EV would increase. Okay, that's how the hybridization will happen. But when we talk about BEV, the source of input power to the motor is only from the battery. Okay, the battery is the only source. So that's the way. And the only way to charge the battery is either you connect the charger, right, or you do a regenerative braking. So these are the only ways, right? So like Aether is an example of a BEV, right? So if you take the smart hybrid electric, which is called in Maruti, that's something like a micro hybrid. Okay, and you have something like a Toyota Prius. They were about full hybrid segment, and they also introduced plug-in hybrids. Okay, if you take Honda, there are few models in Honda. So they are also like the category of mild hybrids. So what is the difference in all of them? That, when you take the full hybrid, so you have, let's say BEV, as you said, the battery pack is very large in size because that's the only source of energy, right, for the vehicle to run. Because if you want a more range, you need a more bigger battery, right? So let's take a battery. So the only source of energy is battery, so that the BEV battery are larger. And typically the discharge rating of this batteries, I'll come to that. There's a word called C, which I'm supposed to cover in the next topics, okay? The C rating of the battery. So typically the C rating of the battery is less than 1C, okay? The usual operation of the battery in the BEV is usually less than 1C, okay? Nominal discharge rates are below 1C. So, but if you go to something like and also if you take a voltage of the battery pack, it is typically anywhere from, depending upon the vehicle segment, 48 up to like 800-volt architecture. Okay, if it's a car segment sort of a thing. So like now, if you consider for the hybrids, right? So like the very interesting thing is the discharge rates of the hybrid cells, the cells which are used in the hybrid vehicles are usually more than 1C. Okay. So that's why it is completely different. The way you select a cell for a hybrid is totally different. The way you select a cell for the BEV is completely different. And the way you do a cooling system for the hybrid vehicle is completely different. The way you do a cooling system for the EV is completely different. So there's a different type of complete cell chemistry itself, as in part of HEVs and part for BEVs. So there's a lot of difference like this. There's a voltage architecture. Even in hybrids, we have micro hybrids, right? Which I was mentioning about. Some of the micro hybrids are 12-volt architecture. Okay, some are 48-volt architecture. So like that, there is a complete difference between what is VAS, even though it's part of EV. So, but there is a complete difference in terms of the system, its architecture, the component selection, the component sizing, the way the component operates, the points of its operation. All these are different. Okay, so that there's a lot of difference between the hybrids and the BEVs. And the control strategies for BEV is again completely different compared to XEVs. We have more complex requirements because there are more systems involved in hybrids, right? You have engine, then we have battery. So you got to balance, and then again you have regenerative energy. So you always have to balance the battery SOC. That's another jargon, right? So state of charge. So between a specific range of values when you want to run the vehicle, and also have to get a maximum output of the vehicle. So as the system goes on complex, then it is difficult to manage. So obviously, we rely on controls. So the controls also becomes more and more complex, right? So this is a lot of things, and in a very simplistic way. But again, as an engineering goes, because this vehicle has taken at least about 5 years of development cycle, right? We can't just talk in 5 minutes of a topic, but it's just a simple overview to understand. Okay, there is a lot of difference. The complete system architecture is different. The components are different. Okay, you can't compare to EV to BEV, or you can't just use the batteries which are in the EVs to hybrids, or you can't just use the batteries which are in hybrids to EVs. That doesn't make any sense. Okay, completely any sense. So the expertise is completely different. Okay, this is what the first layup sort of a thing, which gives you a maybe clear understanding of BEVs and EVs. Okay, so we seems to have good questions out here, guys. Try to drop the questions not in the private chat, because I won't be able to access them on my screen. So, okay, do we have any hybrids for two-wheelers? There are few hybrids people have tried that didn't work really well. But yeah, so people have dropped it. There are like even TVS has models which were in place and good in shape, but I'm not sure that there's a market. Uh, they're complex, the cost is more, the two-wheeler market itself is very outside of a cost effectiveness, so you don't tend to make the technology that affordable as of now. And definitely more components, more BOM, obviously the part cost is going to increase. So C is okay, so I'll come back to that, Zishan, for that question. I don't, okay, right. So great. So any questions you guys have, so kindly do drop those questions, I should be able to take them up. Right. So then when we go to charger side, right? So now we know, okay, there is a EV, right? So we're going to talk more about EV than XEVs. So it's, let's say, BEV, right? So now we have a battery, which is a main source of energy storage system, right? So we need to charge the battery. So if you want to charge the battery, so you got to have a source from where you charge it, right? So the whole set of equipment which comes to charge, supply energy to the battery would be called as, EVSC. Okay, so electric vehicle supply components. So these components are the one which ensures that there are a lot of safety, there are a lot of communication between the grid and your vehicle to ensure that there is always safety for the charging thing. Though that's all called as an EVSC. The EVSC is always about the charging side of it. That's why you see a lot of places they mention like EVSCs, EVSCs, EVSCs. So anything that comes typically in the areas of chargers, that all comes in the areas of EVSs. Okay. So again, we have two type of charging. So like one is like onboard charger type of charger, and then it's also there is one more called offboard charger. So we'll talk about all these things in the later stage. So going to the next one, there is in EVSC. So there are different levels of charging. Okay. So these levels are a little tricky to understand because we don't in India, we don't have 120 volt architecture. So in US, they have 120 volt. They also have like 240 volt, then something ahead of that. So in India, we just have like 20 volt architecture. That's typically what we get at our houses and things like that, right? So we may not have like, this one in India, but typically the levels are defined as per in US. So this is how the way it looks like. So what is it as level 3? So level 3 is about 480 volt and above. But this is sort of not, very straightforward, because typically level 3 is also called as DC. Okay, so let's go back and try to understand what this levels in typically means. Again, as said, these levels are defined with respect to, let's say, the rate of current that you can, I would say that in a very simplistic way, you can power is equal to V into I. So you can define with respect to the amount of power that you flush in to the battery to charge it as fast as possible. So that's the whole purpose of defining these levels. Okay, so higher the level you go, higher the amount of energy which you can flush into the battery. So that means you can charge it quicker and faster. So that's the way how these levels are defined in charging. So in India, maybe the level 1 is different. Then the values of level 1 is different. The values of level 2 is different. So what do you have? Like in India, we have like 220 volt, and we get about 6 amps. That's through our small sockets, which we get in our country. So then we also have 16 amp architecture, right? Then we also have like 32 amp architecture. Yeah. As we go on, we have different levels of, if you go to industrial power supplies, they have an higher ones. So as we see here, like anything as a number which comes here, so depending upon also that we have defined in our country. Then when it comes to our very higher ratings, we have DC charging. Okay, so what is this AC charging and DC charging? Okay, these levels are definition with respect to the country. So this definition is right here. Okay, if you come to our country, where we got to figure out what is this levels law, we can definitely go to the website, and there's a lot of publications available. So it's like if you go to Europe, or if you go to Japan or somewhere else, they have their own way to define this, the values of level 1 and level 2 and level 3. So basically this defines the overall input power to the vehicle. So again, in charging, when we say EVSC, there's something called AC charging and the DC charging. Okay, so what does these things mean by AC charging and the DC charging? So what we get at our house is typically AC, right? So that is what we get at our house. So like we need to convert, but the battery stores the energy only in the DC, right? So we need to convert the AC to DC, so that you can supply that to the battery and to get stored in the chemical format. right? When it releases in the DC, correct? So then you got to convert that to AC if the motor runs on AC, traction motor, right? So this is the whole thing which is going on. But anyway, we are only interested till here right now. So you get AC, so you supply AC, so you have certain interaction which is happening here. That it is not actually doing anything much. It is just a device where it authenticates, it ensures the communication, it also ensures some amount of protection, which is the component which is here. And then we have a component which goes here, and then there is a charger which converts this thing AC to DC, and then it just pushes up here. So what happens in AC charging is, so we supply AC to the car, like we supply AC to the car, and then inside the car we have a converter. So we have an onboard charger. Okay. So the very interesting thing is what happens when we have a situation like Tesla. Okay. So what is the limitation of AC charging? I will come to that, and we will just go ahead some of the innovations done by Tesla too. I mean, very simple thing, but it's also can be called as an innovation. So like we discussed that in India we have like 20 volt, and let's say the available source is about 16 amps, right? So if we sort of make like 220 volt into 16 amps, you get about 3520. So it's close about like 3.5 kilowatt, right? So if you have a Tesla, like which is about like 70 kilowatt battery pack, right? So it's like, if you consider like bare 100% efficiency, so it's never can happen though. So it's 3.5 divided by 3.5, because that's what you can supply for an hour. So you get about 20 hours, right? So definitely this is impossible. So because you have conversion losses, right? Sorry. So you have conversion losses, and all these things are happening here. Then again, when you charge the battery, there are a lot of conversion losses, right? Because you're converting AC to DC, and then you're storing the DC, which is in a current, to an electrical chemical format in the battery, right? So there is a conversion. So typically we call about 20%, right? And it's not that we always can operate a system at a full load. So you would not have the 3.5 as an output. So you would have lesser than that. So typically it doesn't take 20. In a reality, it would take about 30 hours, something like that, or even more than that. So like, can somebody wait for 30 hours? It's like a 24 hours, right? So everybody want like an overnight charging. Like if you keep the vehicle for overnight, that it should be charged. So what Tesla did is they kept two onboard chargers. It's an interesting thing, right? I mean, who would have thought about it? So like you can supply like 16 and then 16. It goes to the, if you can supply 32 amps as an input, so that goes to the two chargers which are sitting inside the vehicle. So you can supply one output of X from here. That's possibly, let's say, like one of 3.5, one of 3.5. So you could club that up. That comes about 7 kilowatts. So what you did, you reduced the time to like 15 hours in the reality. So this is something that can be doable. Like they have already done it in some of the vehicles, which also at a slow charging phases. So that's the limitation of AC charging. So the possibility is, how much you can keep. Can you keep like 3? But your also input is limited, right, from the grid, and you got to have like too many number of connectors to charge the vehicle, and each connectors cost like a lot of money. So you can just keep plugging the more number of connectors. So there is a limitation what we can actually charge in terms of how much flush you can do to do with the AC, right? And your grid should be also supportable for that. That's the other limitation in the one end. So one other end is like, you can't keep too many chargers on onboard chargers on board. Typically, it adds a component size, it adds a cost, it adds the reliability issues, and everything goes wrong when cost goes wrong, when reliability goes wrong. Because more components, there are more chances to failure, right? So this is somebody not want to repair their vehicles quite often. So like now we have a limitation that we have a limitation at the grid. We also have a limitation on the vehicle when you do a charging with AC. So what they did, they went to something called DC charging. Okay. So what is this DC charging? So DC charging is something where it's also called as a fast charging. So what we do, so again, the thing is, it's very important to know for the DC charging, you can't connect to a normal grid, okay, which comes to your house. So there is a very specific grid line which is available for this high voltage chargers, DC chargers, like fast chargers, okay. So Tesla's like latest generation, they tell about I think 120 kilowatt rush. Okay, even I think the CHAdeMO defined close about 400 kilowatt, I believe. Like I'm not very sure on this number because I remember it is 1000 volts up to I think it's 400 amps. Okay, this is what they have defined. I mean that should be basically 400 kilowatt, right? P into I. So it means like you can rush this much of output from the CHAdeMO with their I think CHAdeMO 2.0. When you consider like where is the 400 kilowatt availability at the house grid, it is impossible to get this much, right? But if you go to a industrial power supply, they get about 44 kV. When you define that it's about 44,000 volts, you can put the transformers down in the line, and this can convert that input to a specific voltage ranges, and then you can arrange your current requirements as such by arranging the system of transformers and everything at that place. So that's what people does at a DC fast charging requirements. That's why DC fast chargers cannot be installed at your houses. They need a very specific location to be installed, and because that location has to be supplied with that input power. So you get that. That's what you should understand, because the component cost is also very high. Why it is very high? It's not just component cost; it's also a grid, right? So you have to pay, like if you want to take a house, you may have to pay like 50 lakhs, 40 lakhs or something like that just to set up this whole infrastructure. So it's not going to be workable for you, right? It is workable only when like maybe a big organization or a company want to set it up. So that's the way ahead, for DC chargers. So technically, what is it? If we have to understand technically, so that the thing in terms of it is, there is a device which sits between the vehicle and the grid. Okay, that's basically the device which converts the AC to DC, and also it regulates the amount of voltage and the current that goes to the battery. All right. So what is this interesting thing apart that this charger does? This charger, more of it takes care of communication. Okay, it takes care of safety, but this charger takes care also the conversion efforts. Okay, and also the regulation efforts. So what exactly you mean regulation, right? So the regulation means this, that okay. So see, the charger is there. This is the example of a Tesla charger, right? So forget this Tesla charger. I have some other chargers which is available here. I'll go to that. So we have many different type of chargers. Typically, we have like CSS and CHAdeMO, and then GBT. We also have, I think, SAE, standard SAE plug is there. Like in similar, Tesla has their own proprietary plug, right? So what happens is like, I don't own Tesla, right? So I own something else as a car. Let's say I have Nissan Leaf. I go to the CSS station. I go to this charging station, which is a DC fast charging. But my car doesn't they doesn't know, this charging station doesn't know what is the battery that is there in my vehicle, and what is the information that the required for the charger to charge the battery, right? So what is the meaning? Let's say your battery is 50 kilowatt. Okay, what is its voltage? What is its maximum charge current? Does this charger know? DC charger? No, it doesn't know at that point. So what happens is when you connect the charger, so they both talk to each other. The charger and the vehicle, they will talk to each other through some like communications, like CAN communication typically. That is what is a trusted way of communication. So that is what is majorly used. So they talk to each other, and then there is an ECU inside a car that sends the information back to the charger, and the charger will understand, okay, battery voltage, battery temperature, battery current, battery temperature, how much the rate of charging it should do, all these things, these things it will calculate. Then when they authenticate each other that this is what is confirmed, then only the charger can start the charging process. Again, there are a lot of things which come in between. There is something called contactors, engaging of contactors, the continuous monitoring of systems. All these things are like happening quite inside in place. So, but like there is something which is happening in between to ensure that this charger, because this charger doesn't know, right? So it's like your phone. You take your phone and the one supplied charger, it would understand more of it. But if you connect a slow charger, Does it really understand? So it doesn't understand, but there is a BMS sitting inside. It ensures that it doesn't get rushed the current to as more than limits. But here it is a completely different requirement, because you're giving an authority to the charger itself, because there is no much functionality of the BMS being involved to charge control. So it's completely the DC charger that is like fast charger, which is taking care of the charging process. Okay, great. So somebody has put up a question: what is contactor? So contactor is like a relay, or you can call it a switch, which is electronically controlled. Okay, so it is you can if you know relays, that's how you can relate, or you can also call it a switch, but it is an electronically controlled device. So because we use the main name called contactors, because they are operated at EV at high voltages. So I think I gave you an answer. I can put that in the next presentation too, which is specifically as contactors. Oh wow, we have a lot of topics to cover. That's quite interesting. I'm not sure you guys are feeling bored. You guys are feeling busy with this presentation. So like, please let me know, and feel free to tell on the face it is good or bad for you, if it is going on well for you or not going on well for you. I try to go faster. Ramesh has a question. Can you brief me the term called contactor? Okay, yeah, Ramesh, as I told you, it's basically a relay. I mean, if you know the concept of relay, right? So low voltage circuit, high voltage circuit, low voltage circuit controls the high voltage circuit, right? So it's like this, you have, let's say, a 500 volt that is going in here, and the 500 volts is going out. Okay, so let's define it here: 500 volts and 500 volts. But you're the ECU, right, which is supposed to turn on and turn off this thing, which is basically this system. You have the ECU, so that works at 12 volts. Okay, so now at 12 volt system, let's say even the controller works at, let's say, 3.3 or 5 volts, but that's the different thing. So you want this system to get turned on or off, make the circuit or break the circuit, basically, by with a 12 volt system, right? So it's a very high volt. You cannot let this 5 volt come into the ECU, because it will just burn off and become a charcoal. So you don't want that to happen. So you want the system to get controlled by a 12 volt system, right? So at that time we use this device called contactors. I believe that I gave some idea. I mean, I can do that definitely very in detail for you when I can do the next presentation. I'll make a note of that to cover up the contactors. Yeah, great. If you got it, perfect. So is the battery charging C rate defined earlier? Yeah, Ritesh, that is true. The C rates are defined very much earlier, when there are a lot of testing things that happens. I'll try to do, not possibly today. I'll do it in the next upcoming sessions for sure. There is a defined C rating for the battery, which has already been mentioned by the cell manufacturer. Then the vehicle manufacturer also does some testings and then approves the charging. So like, not all the cells can take a fast charging. Okay, only specific cells can take a fast charging. So that is also a very important point. So according to that, the cell manufacturer defines it. The vehicle manufacturer also defines it. That is stored inside your ECU. When the fast charger is connected, the ECU communicates what's the max current it can take, and that's how it will be distributed across. Cool. So could you please explain later about the current capacity of battery pack, how to select? Oh yeah, Piyush, I think it's possible, but that's a very large topic. Maybe I would definitely try touch basing. Great. This C rating affects the charging configuration. What do you mean configuration? I mean, if you define the configuration a little in detail, do you mean the charger side, or like battery side? I didn't understand the configuration meaning. Yeah. Cool. So the moment you guys drop in the questions, I'll just try to cover up. Yeah. So see what? No, it's basically like this. That if you go back to the last slide, I was just trying to go in here. So what happens is these chargers are smart and intelligent. Okay. So the meaning of that would be this this charger, which is here. You know, it can it can it can supply. Let's say, give an example. Let's say 120 kilowatt is what is its peak. It is not that you can only supply 120 kilowatt. It can even supply like 5 kilowatt. Okay. like per hour. That's it. So it can also supply like 25. It's like based on what we want at our vehicle. Okay, so it is not a factor for that, because you will have all this smart controls and algorithms that are running inside. They can ensure that the engagement is controlled. Yeah, so there is no much hardware changes. Like if you have only for this car, if it is only 10 kilowatt, how do I do that? That is taken care by your charger. Like there's a smartness sitting inside the charger. Okay, I think you got it, Pritesh. When you're talking about power conversion converters, is there a PCB manufacturer in India available with the control system? Hey, there are a lot of companies already coming up. I don't know whether they import and sell it here, whether they indigenously manufacture and invented here. But though there are definitely, the delta is there. They are setting up a lot of charging stations, and Exicom is there. They are setting up charging stations. Uh, Even Ola Electric is getting big into charging stations. So though they are, but I don't know if I can promise you that that's actually manufactured and they're developed here. But there are suppliers in India to do these things. Yeah. So cool. So if we just cover up this one slide, because I said about 5 minutes on the topic. So I'll cover up this one thing and then we will continue this discussion in the upcoming weeks. So there is something called this plug. Okay. So this is the CHAdeMO, or we have some words called CHAdeMO, CSS in my last discussions. This is called CSS. Okay. It's defined under the standard called IEC 62196. So IEC 62196. Basically, this is the IEC is typically when you see IEC, it's parts related to Europe. Okay, that's majorly what drives around in Europe, and JEVS. It's basically Japan Electric Vehicle Standards. So, like if you see about CHAdeMO, that's from that they are always in relevance to JEVS. So each country has their own standards to be maintained. Typically, IEC is for what European continent. So what happens in CSS? Okay, what is CSS? It's combined charge. So where you have the advantage of CSS is you have AC, also DC. Okay, it means the CSS is a plug. Okay, and also a whole charger architecture. It can do AC charging, also DC charging. Okay, if you go back to any of the previous slides, if I was trying to kind of put across this one. Okay, there is AC, there is also DC, right? So there's a AC side and also there's a DC. This is a slow charger and this is a fast charger. Okay, so imagine you are at a parking lot at the cafe, or let's say at your office. Okay, there is one charger which is there, and this is a charger, and you have a car. So your car can only take slow charging. It is not suitable right now for a fast charging. Okay, or else like if your car is suitable for fast charging but you don't want to do a fast charging. Okay, so what you can do at that time, but this if this charger is only a fast charger, you can't connect this charger to the car because it doesn't work, right? But the CSS is something they implemented. You can do AC, you can also do DC. Like in the AC you can do like L1 and L2 also, and you can also do the DC part of it. But that's the beauty of CSS. So this is basically a specific charging standard that is typically from Europe. The advantage, as I was mentioning, it's basically can do AC, it can also do DC. Okay, so in similar we have CHAdeMO, which is this one, which is visible here for you. Okay, so but it can only do DC. Okay, the CHAdeMO cannot do AC, it can only do DC. Okay, so then in similar we have SAE J1772. Again in that they have like level 1 and level 2, L1 and L2. This should be the L1. It means it can only do AC. Okay, I think in level 2 they introduced DC also in SAE. This is a SAE plug. SAJ1172, I think. Yeah, so this is a ChargeMo plug. So this are the components which comes as a part of the charging. Like, we are still at EVSC, okay, a part of the EVSC systems, basically. All right. So we will try to, we'll go to the cell sections in the upcoming webinars, which are coming on every Wednesday. So because I promised it's 30 minutes, I should not overrun and I should respect everybody's time. So I do have a lot of topics to cover in the upcoming days, and I would send you a Google form to all of you, so that, if you have any questions, you can definitely drop those questions over there. And for me to cover up some different topics for you, I will surely try my best to my knowledge to cover those topics and keep it interesting for you. So I believe I don't want to be like, very long, boring sessions for 1 hour, because I heard from a lot of people that, if it's 30 minutes, it's very, quick and, interesting that, the human's concentration can stay for 40 minutes, right? 45 to 40 minutes. So I think it's better to not having a long conversations. So, and also you get some time to digest this information, which is sort of shared across to you. Yeah. So let's stop the topic for today, and the upcoming webinar will be on Wednesdays. So we tend to keep Wednesdays as webinar Wednesdays at Decibels, that somebody from Decibels, or like we will invite an expert or somebody from industry and things like that, so would share the knowledge across, and that legacy will continue for every Wednesday. So every Wednesday, the same time, the same meeting ID, you can join. Yeah. So that's possibly how it goes on. I believe it was interesting for you. I believe it was kind of informative for you. So please do drop in the chat box. It was really useful for you. If not, what to improvise and things ahead. Yeah. By the way, thanks a lot for participating for today's discussions. And I wish you all happy good night, and keep learning. And we'll see you to catch back on next Wednesday. Thank you until then. Bye-bye.